Hello viewers. Today we are going to tackle radioactivity. So I have some sample questions on radioactivity. They're not much. It's a very easy topic in chemistry. I don't know why students normally have challenges in answering them. So I'd like us to begin with the first question. We are asked complete the equation by determining U and V. So we have such an equation. Now in radioactivity, we have unstable nuclides when they disintegrate to produce other nuclides, and these ones are called particles, and energy. That process is called radioactivity. Now generally, as we look at this question, this 234 normally stands for the mass number, and 90 is the atomic number. So this one is a nuclide. In this case, we have the mass number 234 and the atomic number 90. This one is the mass number, and this one is the atomic number. Now, E 0, -1, this kind of particle is normally called the beta particle. Now, when beta particles are released during a radioactive decay process, the mass number remains the same. It therefore means that U will be equivalent to 234, and the atomic number normally increases by 1. Now, some students normally confuse that if it is -1, we're supposed to subtract 1. But in real sense, when it is -1 here, this V, this one is supposed to increase by 1, and therefore V will be equivalent to 91. So whenever beta particles are released during a radioactive decay process, the mass number remains the same because it is 0, and the atomic number increases by 1, as we have in such an equation. Now let's go to the next question. We're asked a very simple one. Distinguish between nuclear fusion and nuclear fission. Now, from the word fusion and fission, fusion comes from the word fuse, and fission comes from the word fizz. Now, what do I mean by fuse? Fuse is to come together. It therefore means that the definition of nuclear fusion is the process by which light and unstable nuclide, they are light and unstable nuclides, combine together by releasing another nuclide, energy, and particles. So nuclear fusion is whereby light and unstable nuclides combine together. But when you talk about nuclear fission, we talk about heavy and unstable. So when you talk about nuclear fission, is whereby we have heavy and stable nuclide disintegrate when bombarded by a. So as I said earlier, nuclear fusion is whereby light and unstable nuclide combine together. And when I talk about nuclear fission, is whereby heavy and stable nuclides disintegrate when hit by a fast moving neutron. So basically, when you talk about nuclear fission combining together, when you talk about nuclear fission separating, and in such a case we must have heavy, and in nuclear fission we must have light nuclides. Now let's go to part B. We are asked uranium-234 disintegrates by emitting an alpha particle.
No, uranium-234.
Okay, we have uranium-238 disintegrates by emitting alpha particle to form substance Y. the nuclide Y emits a beta particle to form substance Z. Write down the nuclear equations to show how substance Y and Z are formed. Now, when we talk about an alpha particle, they are normally represented by helium, and helium has mass number 4 and the atomic number 2. When you talk about a beta particle, they're normally represented by electrons, where the mass number is 0 and the atomic number is -1. And in such a case, when we have uranium 238, and the mass number of uranium we were given to be, not the mass number, but atomic number as 92. Atomic number to be equal to 92. It therefore means that if you are given uranium 238, they actually mean the mass number, and the atomic number is 92. When it disintegrates, we've been told that it forms substance Y, and substance Y is formed when an alpha particle is released. And when an alpha particle is released, we have 4, 2, and helium. Now, when alpha particles are released, the mass number decreases by 4. So in such a case, it will be 238 minus 4, which will give me 234. And the atomic number decreases by 2, so it will be 92 minus 2, which will give me 90. So this is the equation for the first reaction. And then the second one, we've been told that nuclide Y23490 emits a beta particle to form substance Z. Now, Y is 23490. When it emits a beta particle, it forms substance Z, and beta particle is 0, -1e. So when beta particle is released, I say that the mass number remains the same, 234, and the atomic number normally increases by 1. So it will be 90 plus 1, which will give me 91. So these are the two equations that we are supposed to write down. Now, let's tackle the final equation. We've been asked a very simple question. State one way in which nuclear reaction differ from ordinary chemical reaction. Now, nuclear reaction, just from the word nuclear, it takes place within the structure of the nucleus, where it involves protons and neutrons. So when you have nucleus, so it takes place within the nucleus of an atom, and it involves protons and neutrons. And when we talk about chemical reaction involves electron loss and electron gain. So that is one of the major difference between nuclear reactions and ordinary chemical reaction. Nuclear reaction takes place within the nucleus of an atom, where it involves the protons and neutrons. But an ordinary chemical reaction, it takes place on the outermost energy level, and it involves loss or gain of electrons. Furthermore, nuclear reaction produces large amount of energy when they take place. Conversely, chemical reaction normally produces lesser amount of energy as compared to ordinary nuclear reaction. Thank you very much. Let me write the next questions. We've been asked this. So this is our final question. We've been asked, why gram of a radioactive isotope takes 120 days to decay to 3.5 grams? The half-life period of the isotope is 20 days. Find the initial mass of the isotope. Now, there are two ways that you can approach this problem. We have this formula, and then we also have a long method that you can approach it. So on this formula, for us to get the the remaining amount, or the mass of the remaining, is equals to the original times half power n, and n is the number of half-lives. When I say t a half, I just mean the number of half-lives. And in our case, we've been told that y is the y gram. So y gram is the original mass of the isotope, and then the number of days, the total number of days it takes to decay to 3.5 grams. So we have the number of days. So for us to get n, we take the total number of days it takes divided by 20. And 20, we were told that it is the half-life period. Like one half-life takes 20 days, and the total number of days is 120. So to get the number of half-lives, it will be 6 half-lives. So if we have the value of n, and the original is what we want, and the remainder is 3.5, we can get the value of y. Therefore, I'll say 3.5 is equals to y times a half power 6. It therefore means that y will be equivalent to 3.5 divided by a half power 6. And if you use your calculator, the answer will be automatically 224 grams, and that will be the answer. So we have another way that we can approach the problem. We have the number of half-lives as 6, and the final mass is 3.5 grams. It therefore means that we go 6 steps. If half-lives is 6, we go backward 6 times. Now, what is the definition of a half-life? Half-life is the time taken by a radioactive isotope to decrease by half of its original. So if this is the remaining amount, for me to find the original amount, I will go 6 times. So if this one is 3.5, if we multiply it by 2, that will be 7.0 grams. So T a half. So this is the first half-life, this is the second half-life, and if we go up to 6 times, the answer should be 224 grams.